Dear students, today we'll start with a very good chapter that is called continuity and differentiability. So, if you start with that chapter, continuity, very simple thing, we call a curve is continuous. See some curves here. Suppose I get a curve like this. I can say from this point to this point the curve is continuous. You can call a continuous. Suppose this is A, this is C, this is suppose D. I can say the curve is continuous in the closed interval A. Means I cannot find any break in the curve. Similarly, if I do another one, I can say this is a curve which is A here, C here, B here. When I talk, a curve is discontinuous from A to B, because in between you find a point where the curve is broken, and again from here it starts continues up to B. So I can say the curve is continuous from A to C, the curve is continuous from C to B, but the curve is continuous at a particular point, that is at C. That is what we are going to discuss. So here you can say the curve is continuous in open interval semi-closed A to C and in C to B, but discontinuous at x equals to c. This is the graphical concept we say about the continuity of a function. Now, mathematically when you write, what are those points we describe a curve to be continuous or a function is said to be continuous? So, let's write the definition. Definition here. A curve or a function fx let's write the function fx is said to be continuous at x equals to c if first point limit extends to c fx exists. The limit will exist. This concept you have studied in class 11, but I am trying to explain it. That is, your left hand limit, see I have written here c minus, equals to the right hand limit. That is called, if both the limits are equal, then you call the limit exists. Then you say the limiting value extends to c fx equals to f of c. means direct value you put, then it will be equal. So what does it mean? This will clear by taking one example here. Look, let me discuss this point. What is that left hand limit equals to right hand limit? Suppose I consider a curve here. Like this. I say y equals to fx is a curve. This is the point I found, C point. Okay. When I say x tends to C minus means any point left hand side. I am taking little far here, just you will understand. Suppose I have taken this point. For any small value, if this I consider as h, then this point will be x minus h, sorry, C minus h. Now I will consider there is a broken part here because of this point. This point is C plus h. I have taken far out from here. Or very clearly if you are right, this is C plus h. So left hand limit means this length. If this length is not equal to this length, then we say left hand limit is not equal to right hand limit. This is the value of left hand limit at which point? C minus h. Means you take a neighboring point to C. Neighboring point means you take a value left to C and right to C. And if you see these two lengths are not equal, then you say the limit doesn't exist. Means left hand limit equals to not equals to right hand limit. But you have to notice here, when you are going to calculate this left hand limit, you are going to put the point C minus h. And when you are going to calculate the right hand limit, then you are writing C plus h. If these two are equal, then you say limit exists. If these two are not equal, then you say the limit doesn't exist. So this is the graph I have drawn here. This is the limit x tends to C minus fx. Here is not equal to limit x tends to C plus fx. Okay. What about the limiting value equals to functional value? To understand this, let us draw one more graph. Suppose I found a curve here. This is the point C. This is your left hand limit. Look, this is your left hand limit. This is your right hand limit. These two are almost same. But if I take a line and I consider this is C point, mean this is your FC. Which part? This part is FC. If suppose this is your FC part, then you see your left hand limit equals to right hand limit, but the limiting value and the functional value, they are not same. So still also we call this is discontinuous function. This is discontinuous. Here fx is discontinuous. Here fx is, you can write limit x tends to C, means left and right limit is not equal to your functional value. This is your functional value. Okay. So also fx is discontinuous. Okay, now. Then what about taking all these points continuous? Let me consider a graph or I consider a graph. This is the point C. Then if I join here, this is my FC. This is your left hand limit. This is C minus H point. This is your C plus H point. I see left hand limit equals to right hand limit. Again I see left hand limit equals to functional value, because this length, this is the same length. These two are equal. These two are equal. Again functional value equals to right hand limit. If this condition happens in the curve, you call the function is continuous. So these are the basic ideas about the continuity of a graph. What we'll do now, we'll start solving some problems based on this, and you will see that the concept is getting clear step by step. Suppose I write a question. Discuss the continuity of the function fx equals to fx equals to 2x minus 1. Remember the degree of 1, degree is 1 here, at x equals to 3. Means this is a straight line like this. 2x minus 1 will be a straight line. Then you are considering a point here which is x equals to 3. So we have to check whether this function is continuous or not. So what we'll do is, we'll take some steps here. Now fx equals to 2x minus 1, and c value you have taken here is 3. So what is your left hand limit? LHL. Left hand limit. Now limit x tends to 3 minus. Why 3 minus? Now left to 3. 3 minus 2x minus 1. 2x minus 1. So what is the procedure I told you? The procedure you have to remember here. Whenever it is a left hand limit, you have to calculate in this way. Limit h tends to 0. This becomes c minus h. C minus h means your x becomes 3 minus h minus 1. Now put h equals to 0 here. That will be 2 times 3 minus 0 minus 1. That is 5. Your left hand limit. Okay, let us see right hand limit. Right hand limit. The graph we are showing, you can see it here. It is like this. X equals to 3. This is 2x minus 1. Right hand limit means limit x tends to 3 plus. Now point is 3. So 3 plus 2x minus 1. That means you are taking a neighboring point here. 3 plus. This is 3 plus h. This is your 3 minus h. So how to calculate? Look at just like how did you calculate the left hand limit? Now limit minus h tends to 0. Here will be limit minus limit plus h tends to 0. So you will write that is limit h tends to 0 2 times 3 plus h minus 1. Okay. So now you put h equals to 0. This is 2 into 3 plus 0 minus 1. That is 6 minus 1 again 5. So conclusion, left hand limit x tends to 3 minus fx equals to limit x tends to 3 plus, and the value you got is 5. You got it 5. Now what is your functional value? Functional value means directly you will put f3. So where are you going to put? Now that is 2x minus 1 where x equals to 3 you have to put. So put 3 in place of x, that is 2 into 3 minus 1, that is also 5. That means you got limit x tends to 3 fx f3 which is equal to 5. So all the conditions are satisfied, then you check the graph is continuous. So implies fx is continuous at x equals to 3. So let's understand whether really it is continuous or not. You can draw the graph of this. You can check the graph of this. Suppose I write your 2x fx equals to 2x minus 1. You make a table on this. X, your fx. Put x is 0, minus 1, x is 1, 2 minus 1, 1, 2 2 ja 4, 4 minus 1, 3, then 3, 6 minus 1, 5, 4, 8 minus 1, 7. Now, if I draw the graph of this, now look, 0 minus 1, this is your minus 1, this point 1, 2, 3, 4, 5, like that. Then 1, 1, 1, 2, 3, 4, 5. Take 1, 1, 2, 3, 1, 2, 3, 2, 3, 3, 5, 3, 5, something like that. So you get a graph in this way. So at x equals to 3, you can see there is no break. It is continuous. There is no hole in the graph. So this shows that this is a continuous graph. But every time we will not draw the graph, we will take the concept, we will try to solve it. So let us see. How to solve some of the questions. Suppose discuss একটা মার্কার নিয়ে আসো তো একটা মার্কার আনো মার্কার continuity of the function discuss the continuity of the function hello marker continue the function fx equals to 2x plus 1 where x is less than equal to 1 x minus 3 when x is greater than 1. So your question is given in this form. It is 2x plus 1 x is less than equal to 1 x minus 3 when x is greater than 1. Okay, let's take when you say look at here when I say x tends to c minus that means you are writing c is x is less than c. When I say limit x tends to c plus you write x is greater than c. That means here x is less than 1 means left hand limit, x is greater than 1 means right hand limit. Okay, look at here what do you get? Limit x tends to 1 minus. You can write here if the question is at x equals to 1. So 1 left hand limit fx. So this is limit x tends to 1 minus fx means 1 less than 1. Less than 1 is 2x plus 1. So 2x plus 1, how to calculate? Already I have told you. So that will be left hand limit means limit x tends to 0 2 into limit minus h. That is, what is your limit? 1. 1 minus h plus 1. Now you put h is 0. 2 into 1 minus 0 plus 1. That is 2 plus 1, that is 3. Go to right hand limit. So right hand limit, limit x tends to 1 plus, limit x tends to 1 plus fx. So 1 plus is greater than 1. So this is limit x tends to 1 plus x minus 3. X minus 3. So what is the answer here? Now limit h tends to 0, limit plus h minus 3. That means you are getting 1 plus 0 minus 3 which is minus 2. So you can check here the left hand limit is not equal to right hand limit. So here the function is discontinuous, will not go for third point. So we can write directly here implies left hand limit not equal to right hand limit. Therefore fx is discontinuous at x equals to 1. Okay, let's take another question. Discuss the continuity of the function fx equals to minus 1 when x is greater than 2, x plus 3 when x is less than equal to 2, at x equals to 2. Look at here. How it is defined? Your right hand limit is given, the value is minus 1. Your left hand limit is given you x plus 3. Equality, functional value when it is equal, x is 2, also x plus 3. So discuss whether this equation, this function is continuous or not. The procedure will be same. The solution. So first you start with your left hand limit. Limit x tends to which point? 2. So 2 minus, because you have taken left hand limit. 2 minus means less than is 2 minus, greater than is 2 plus. So 2 minus means you will write here x plus 3. So what is the procedure now? How to calculate? That is limit x tends to, we'll change the limit, h tends to 0, 2 minus h plus 3. Limit minus h, limit means 2 minus h tends to 0. So that becomes 2 minus 0 plus 3, that means 5. Okay, you go to right hand limit. Right hand limit was limit x tends to 2 plus, and the value is given here minus. So that is minus 1. There is no need to take any change here because this is a constant function. So directly you can write the value is minus 1. So left hand limit is 5. Right hand limit is minus 1. So again you can write your left hand limit is not equal to right hand limit. So conclusion is implies fx is discontinuous at x equals to 2. Okay, let's take some more problems on this, so that will again clear us. So discuss the continuity of the function fx equals to 2x plus 1 when x is less than 0. This is 1 when x equals to 0, and it is x plus 1 when x is greater than 0. Let's see whether this function is continuous or not. So at x equals to 0 means at 0 point you have to show whether this is a continuous or not. So what are the steps? Only 3 steps you are going to remember. What is your first step? That is left hand limit. So left hand limit means which one will be left hand limit here? Now less than is left hand limit. So point is what? Point is 0. That means you are writing limit x tends to 0 minus. When it is 0 minus, what is your fx? Not 2x plus 1. How to calculate? Left hand limit is limit minus h. So this will be limit h tends to 0, 2 times limit is 0 minus h plus 1. Put h equals to 0. that is 2, 0 minus 0 plus 1. The value is 1. Okay, the value is 1. Go to right hand limit. RHL. The RHL gives you this one. So what shall I write? Now limit x tends to 0 plus right hand limit x plus 1. So I have to write limit x tends to 0, limit plus h, 0 plus h plus 1. Then it becomes limit, already you have taken here, directly put the value 0 plus 0 plus 1, this became 1. Here you got your left hand limit equals to right hand limit. Then what I have to do? Therefore, left hand limit equals to right hand limit means limit x tends to 0 fx, that became 1. So when the limit will exist, we will go to find the functional value. So functional value means f of 0. Directly you are putting f of 0 here. F of 0 means x equals to 0. When x equals 0, the value is given you 1. No need to calculate anything here because it is already given. So that is 1. Therefore, limiting value equals to functional value. Implies limit x tends to 0 fx equals to f0, which is 1. Therefore, fx is continuous at x equals to 1. So that equals 0. Okay. Let's take one more question. First, you define modulus function. Modulus function you might have studied in class 11. Once more I am reminding you, mod of x is defined as x when x is greater than equal to 0 minus x when x is less than 0. This thing you have to remember every time because we will be using in almost all the questions in the continuity. Say, discuss the continuity of the function fx equals to mod x by x when x is not equal to 0 and it is suppose 0 when it is 1 when x is equal to 0. So for this we have to define this modulus function first. So we have to define the modulus function. Fx equals to mod x is x when x is greater than equal to 0. X is, I think it's not clear, I will show you here. Mod x is defined as x when x is greater than equal to 0 minus x when x is less than 0. That means from here you are finding your right hand limit, you are finding your left hand limit. Okay, then how to do? Let's take the function. Now left hand limit. So left hand limit x tends to 0 minus function is mod x by x. Limit x tends to 0 minus mod x by x. So 0 minus का meaning less than 0. Mod x का value minus x. So you are going to write minus x. This one will change. This will not change because this one is a definition of x and minus x. So that is limit x tends to 0 minus x by x. Now this is cancelled, which is minus 1. So directly you found the value minus 1. Now write a limit, that is limit x tends to 0 plus mod of x by x. So 0 plus means what? Greater than 0. So when greater than 0, mod x is x. Only this one will be changing. That is x by x. Second x cancel, that is 1. Your left hand limit is not equal to right hand limit. So you can write here left hand limit is not equal to right hand limit. So again you find fx is discontinuous at x equals to 0. So we have taken a first class of this continuity. You try to practice some more questions based on this. Tomorrow we will start again same thing.